A circular economy is defined as a type of economic system or model that minimizes waste and pollution, maximizes resource efficiency and reuse, and designs products and services to last longer or be recycled. A circular economy's goal of perfect efficiency happens to be shared by the theory of perpetual motion. The concept of perpetual motion can be defined as the action of a device that, once set in motion, would continue in motion forever, with no additional energy required to maintain it. Unfortunately, the first and second laws of thermodynamics deem it impossible. However, this has not stopped inventors from trying to outsmart these natural laws with designs such as the overbalanced wheel, which can be seen in this picture. A similar attempt to defy the first law can be seen in the design of the closed-cycle watermill. Famed inventor Leonardo da Vinci did not refrain from making his own attempt at perpetual motion. His design featured a variation of the overbalanced wheel, which used rolling balls on tracks within the wheel. I was especially struck by the elegance of this design and decided that I wanted to make my own variation. The first step of my design process was to create a low-fidelity prototype. Although crude, this construction of Legos and pipe cleaners helped me gain traction in deciding the direction I wanted to take my project. Now that I had a general idea of what I planned to make, it was time to start 3D modeling my ideas in SolidWorks. I started with a mold for the vacuum former. This would create the compartments for the rolling balls. Next, I made a series of parts to be laser cut. I started with a base that would support the final assembly. After that, I made a support piece that would hold the rotating elements of the design. Then, I made a simple disc that the vacuum-formed plastic shell would be connected to. And when everything is assembled together, it looks like this. After my 3D modeling was complete, it was time to start 3D printing. Using a Prusa Mark III printer, I printed my mold for the vacuum former. I ended up having to print another component due to a fault in my original design. In order to keep the rolling balls in their respective compartments, I needed a piece to fill in the center of the vacuum-formed plastic shell. I ended up making 3 versions of this part in a pursuit of satisfactory dimensions. I used the Formec 508 DT vacuum former to create a plastic shell of my mold. In order to connect all of my project components together in an assembly, I needed a crankshaft for the wheel to rotate about. I used a lathe to turn and face a piece of 1/2-inch round aluminum stock. The crankshaft had different diameters on each end because one end was pressed into a bearing, while the other connected directly to the acrylic disc that the plastic shell is attached to. The final step of my design project was to assemble all of the components. I started by gluing the 3D printed compartment divider to the upper interior of the plastic shell. After that glue dried, I put a 1/4-inch diameter ball bearing in each compartment and then glued the acrylic disc to the back of the vacuum-formed plastic shell, sealing in the ball bearings. As I waited for this glue to dry, I also glued the non-bearing side of the crankshaft into a hole in the center of the laser-cut acrylic disc. After this step, I attached the acrylic support piece to the bearing. I placed a folded paper towel in between the two pieces while the glue dried to keep optimal spacing and prevent rubbing. Lastly, I slotted the support piece into the base and added glue for more stability. The quest for the discovery of true perpetual motion is the very essence of engineering. The pursuit of perfection has been the motivation for innovation for centuries on end. The circular economy is similar in its goal of wasteless efficiency. Although both of these concepts in their purest form exist only in the hypothetical, it has not dissuaded engineers from pushing the boundaries of what is possible. I find this incredibly inspiring and aim to allow my own creativity to be the only limiting factor on what I can design and achieve.